I'm Matar. I'm from ActiveFence. I lead data and AI there. And today I'm going to be talking about Nazis hate and Gore, as promised, and basically how we detect harmful content at scale. But before we get started, I want to make it very, very clear that what I'm talking about here is a huge group effort. I'm standing on the shoulders of giants, as you see. If what we're doing sounds interesting, exciting, you want to make the world a better place with cool technology, big impact, take a picture, we're hiring. Pull out your phones. Okay, thank you, even if it was just a courtesy picture. Whoops. Right, okay. So at ActiveFence, what we do, our goal, our mission, is to protect the integrity of every online interaction, which will lead to a safer world, both online and offline. We know that our lives are, much of our lives are online, and we also know that online harms can lead to offline harms. So by protecting lives online, we're doing our part to make the world safer. Now, that's great, but how and why is what we're doing any different from any other kind of AI, detection, ML, pick your favorite buzzword? And specifically, here's an example, like why is it any different from car detection? Right? We have tons of companies that do all kinds of detections. Why is this unique? So first of all, harmful content detection is both evasive and adversarial. So here's an example from an e-commerce website. I look at the metadata, it looks fine, domestic tourists, sold for, 31 euro, size small, everything's great. However, if I look at the image itself, I see that it's actually domestic terrorist, not domestic tourist. Domestic terrorist for the alt-right. And so in order to basically capture that this is something violative and shouldn't be on the e-commerce website, I need to do something like OCR, extract it, and then keep going. Okay, so great. So I'm doing OCR, that's fine. Yeah, they think they're evasive, but they're not. And then this comes up. So harmful content detecting it doesn't only require being about evasive and adversarial, it also requires some subject matter expertise. So for example, here's a t-shirt. It says CUE, Q. That doesn't mean anything, right? Just a word. But if you know about QAnon, and we know, and you know about 828, then you know that CUE is just sort of coded for QAnon. And they even say that. They say, we were told to camouflage our channels, so we did so with CUE. Now we don't have the AI finding us. But what they don't know is that we have subject matter experts and we know about this. Okay, so we said evasive, adversarial, requires subject matter expertise, and it's non-stationary. It's always changing. The world is non-stationary, so are hate groups, so are bad actors. So here's an example, Crew 319. It's already old, actually. It's from June 2022. There's new ones all the time. And if you have a model that was trained, deployed prior to this, then it wouldn't identify not this word, or their name, not this logo, nothing. And I don't think I need to convince you that they're vile. Another thing about harmful content is that it's multidimensional. No one says that bad actors need to only use text or only use images. They can use games, they can use audio. So here are some examples from some of our favorite audio streaming platforms. And again, maybe this might require some subject matter expertise to understand what we're looking at. The previous one didn't really. And so here what we're looking at, this is the Iron Cross. It's a neo-Nazi symbol. You see here RHOA, or Racial Holy War. 1488, 14 stands for the 14 words. It's like a neo-Nazi sentence that they use a lot. 88 for HH, Heil Hitler. We also have here NSM radio, so National Socialist Movement, Nazi radio. And finally, a jihadi playlist from our friends up north. So we understand that this is difficult, right? It's multidimensional, it's evasive, it's adversarial, it requires knowing what you're looking at. And really the only way to keep platforms safe is with technology, right? The scale of this is huge. Even if we have 1 million moderators sitting and clicking away, 1 billion moderators sitting and clicking away, they'll never keep up. And furthermore, there's no reason to expose people to this stuff, right? Some things are so obvious that they shouldn't be on there that we don't need people to look at it. And some things are so obvious that they're fine that we also don't need to burn people out and just have them look at it. And so both for moderator well-being and also just because it's impossible to capture all of it with humans, we need technology, and that's where we come in. So like I said, we at ActiveFence, we look at many, many, many abuse areas and many different modalities. So images, videos, audio, text. Today I'll focus on text. So we can detect harmful content in text using keywords, right? So that's easy, that's technology, that can work at scale. Here's some examples. And so here's a post on a channel, and you guys already know, 88, Heil Hitler, you guys are good, you have subject matter expertise already. They're using a slur for transgender people, also not okay, okay? And so we can put all these things in our sort of keyword matching and say, great, anytime 88 comes up, anytime the slur comes up, we'll catch it. And then they also use phrases, and so we can say, that's fine, we'll put the phrases in our engine, and anytime the phrase comes up, we'll get that as well. And then they, remember, it's evasive, and we have subject matter expertise, so we know what this emoji means, right? And so they want, not only do they hate the Jews, they also want to kill the Jews. And also they use leet speak, so they're coding the text with, numbers, letters, whatever. And that's fine, right? We can say, okay, fine, our engine will identify emojis and translate them, and we'll know to translate from leet speak, and everything works well, and we're good, and we can all go home. But is that really enough? Does it really make sense to only use keywords and phrases? So here's a challenge. Can you guys think of an example where keywords might fail if we're trying to detect drugs? When someone's talking about someone else, that's one thing, right? But they could still use, I could put all the words for drugs in my keyword matching. Can someone think of a problem with this? You could use a picture of the molecule. So yeah, so actually one thing that we see a lot with in correspondences about drugs trafficking and solicitation is you can have entire conversations with emojis. Like, that's done. But we know how to catch emojis. So here, maybe this will trigger your imagination. So all of these are stand-ins for drugs, right? Horse for heroin, Mary Jane for marijuana, weed for weed, skunk for marijuana. And so the problem with keywords is that they can often trigger a lot of false positives, right? If I had all of these words in my keyword list, no one could talk about riding their horses with their new Mary Janes drinking cold ice, right? That would be banned. That's awful. And it's not. It's fine. So we know that there's a lot of false positives, and it means that context matters. So here are some examples, real data, of things that we see coming in. And so here's one that's pretty interesting. I like this one. You're just amazing at being useless. So in order to understand that this actually is not cool, it's not nice, you have to understand the full context, and you have to make it to the end, right? Another example, or two other examples, I'm considering jumping off a cliff tonight. That's probably suicide, self-harm. If that was on a child's platform, I would definitely want to flag that. But the next sentence, I'm going cliff jumping for the long weekend, right? They're kind of different. They're both talking about jumping off a cliff. One is okay and one is not, right? We also have, remember we were talking about emojis and drugs, so I got a lot of this and pure that. Okay, we want to catch that. And here's some interesting things. So we're not only looking for harmful content, we're also trying for some clients to motivate positive behavior. So we want like a model that's pro-social, respectful. And so damn, that was an NS. So damn is a profanity. NS is shorthand for nice shot. Damn, that was a nice shot. That actually is positive. Like, that's something that I want to catch as positive. On the other hand, thanks for the free points, that seems really polite, but it's actually sarcastic, and that isn't something that I want to mark as positive behavior. And so we built language models that are able to understand context, and you can see that that's what we catch, right? So we're able to catch harassment and bullying, drugs, pro-social behavior, suicide, self-harm, adult content, hate speech, and we have a ton. These are just some examples that we picked out. Okay? So clearly, context matters. Keywords are important, but not by themselves. And all the time, as we're building this, we constantly need to think about scale, right? And how do we optimize both for the throughput and also for the latency? And one thing is that we basically want to offload as much of the customization to the clients, to our customers. Our customers, in case that wasn't clear, it's any platforms where users can upload content, right? So any platform where there's user-generated content, there's a place where people can be mean to each other, to put it mildly. And so those platforms can basically send their content through our API and then run our detection models and then get a probability of how risky this what this content is. And we want to let them decide what's important for them, right? So if I'm a child's platform, okay, I don't want any harassment and bullying, I don't want any suicide, self-harm, I don't want any profanity, I don't want any sexual content. But if I'm a dating site, I'm okay with profanity, I'm definitely okay with sexual content, maybe not with sexual solicitation. And so I need to be able to be able to let them have that granularity. And so here's just an example from our UI where they can select the different detectors that they want, build their policy, and then run. And this is a bit about what our architecture looks like. Again, very high level. The idea being is that we're really trying to optimize for scale and throughput here while not compromising on quality, right? Because at the end of the day, the goal here is to be able to help these platforms automate the decisions that they make in order to keep their platforms safe. And so you have the client, they send the request, we authenticate, we load the config, you saw the UI for that. We resolve the language, we have really fast ways of doing that. We need to do that because some of our detectors need to know the language, others don't. And then we sort of prepare the request, we set it up, and then we fan out to different detectors, right? Again, we don't want to have any sort of bottlenecks along the way. We fan out, we collect it, we then calculate the score, we can map to different confidence levels. Some clients prefer to get their response in bins. Again, it relates to their automation. And then we can do a couple of things with the response. One is we return the API response to the client. Another one is we send the response to our UI. We have a moderation UI where clients can sort of put their moderators and build codeless workflows and automate. And then we can also send the results to our data lake so that we can use them to then learn from them and keep improving. So that was great. We have clients, we have data, everything's going great, and then this happens. We bought Spectrum Labs, which was sort of a competitor with lots of real-time gaming clients and dating sites focused on text. And so this is amazing, right? We have all these new clients, but we also have a lot more scale, a lot more data, and we need to, we need to scale more and faster. Where did I go? Ah, I'm going the wrong way. Go back. Wait. Where are we? No, other way. Ah. There it goes. Okay. And I saw my slides. But the devil's in the details, right? So everything's great. We bought this company, and everyone's ready to go and excited, but we have more scale. We have to deal with, understand if our architecture, which worked great for the scale that we were at, is appropriate now. Click once. Okay, so we understood that we need to scale more than we were, and we need to scale faster. And we had to ask ourselves some questions. First, how do we test and measure our performance? How do we even know what our quality is, right? If we scale, are we taking a quality hit? Are we at the right performance? So what do we care about? What are the metrics that we care about? Another important question is, what's our budget, right? So we bought this company, we got a bunch of clients, we got a different budget. Now we need are we on budget, are we off budget? Who knows? And finally, what's our cost and how do we even calculate that? So what's my budget? You guys already saw this, so who cares, right? So first is, let's ask ourselves, how much is the client even paying? So these are fake numbers, okay? But let's assume, so this client's paying $3 million annual. Okay, this is their annual price. And then we go and we ask finance, we say, what's the margin that you want? Please don't make it too high. And they say 70%. Okay, so of that 3 million, we're left with 30% to work with, okay? And then we're saying, okay, right now we're gonna be focusing on costs that we can manage ourselves, specifically sort of direct AWS costs. So let's ignore like our metrics and our other tools and our databases. Let's just focus on things that we can directly control on AWS. And so that's about 2/3. Okay, again, we're ballparking it. So that is basically my annual budget, right? After accounting for the margin that I need to take. But that's annual, and I want to try and normalize to like a smaller unit, something that I can work with and understand on the level of a request. So let's convert it to monthly. And what I know is that this particular client has 30 billion requests per month. Okay? So now I do this math, and I say, okay, that gives me the price, or the cost, sorry, cost, not price, cost of one request. But these are really small numbers, and they're kind of hard to compare, and you look at them on your spreadsheets and they make no sense. And so let's just convert that to something that's easier to think about. Let's convert it to a normalized unit of measurement that then I can compare every time I'm running different tests or looking at my budget. And this is as if it was 1 request per second per month, okay? So all I do is I multiply it by the number of seconds in a month. And now I have a number that is basically my budget for 1 request per second per month, okay? If that doesn't make sense, because I blew through it and one of my colleagues said that the equations in the beautiful mind were easier, let me know and we can discuss. But the idea is I want to bring it down, taking everything I know into account for a single unit of measurement. Okay, so great, now we're gonna run our first load test. When we're running a load test, what we care about is we wanna make sure that we're tracking our KPIs, first of all. So we're looking at latency, we're looking at throughput, and we're looking at success rate, okay? Because it's great if we're at latency and throughput, but if everything fails, then who cares? Okay, and then we also said we're gonna try to minimize our variables. So we're gonna start really over-provisioned with all of our resources, because right now I'm not, let's just see that we survive this. Like, I don't wanna test my auto-scaling or anything like that. I'm gonna over-provision and monitor my metrics. I have all my dashboards set up, let's go. So spoiler alert, not good. That's, okay, and here you can see the not goodness of it. So you can see that our request rate, we weren't even hitting 1,000, and already our success rate was only 7%, not good. And if you look at our latency, we're at, our P95 is at 678 milliseconds. Our goal is 200 and less. Remember, these are clients that this is used sort of in automation of chats, so for pre-publish, we need to be able to return a response. This is not good, for like the 5th time I've said that, not good. And we can also see like a bunch of errors, a bunch of status codes. And so we started this, and actually that was really good. It was good that we did this, because now we have to get to work, right? And so we could start working on our different things that we can do. We prioritized, let's start with a low-hanging fruit, move to the long tail, and we kept doing this and iterating on these different things before we could, kept doing tests and load env in our load environment to see how we could improve. Again, constantly focusing on our KPIs that we care about, okay? So the first thing that we did, or not, actually these might not be in order, but one thing that we did is we quantized our models. When we did that, we knew that that would make them smaller and faster, but we also had to make sure that we weren't taking a quality hit, right? We had to make sure, we had to look and compare, and for all the models, and do head-to-heads and side-by-side, and really look and see how is this affecting our results. Because who cares if they're small and fast, but suddenly everyone's a Nazi, not good. We want to make sure that we only do our work once. This sounds really trivial, but it takes a lot of digging to ensure that we're extracting all the work that can be done in one place and fanned out, and not extra work in all of the detectors. This obviously reduces our memory waste. It also triggers less garbage collection, which makes things go faster. We also discovered, as we were running our load test, that the load wasn't distributed equally within the cluster. We had to improve our internal load balancing. Specifically, what we saw is that some pods were getting all of the traffic, and other ones were just hanging out. And this was especially when we would sort of add more pods or spin up, they were just sitting there, and the traffic was just getting sucked in to particular pods. And so in order to do that, we had to sort of look at the load balancing. We ended up going with ALB, and we had to select also the optimal policy for how to separate, for how to share the load. And this improved our performance dramatically. Another thing is when we did get to auto scaling, we had to obviously fine tune the HPA, look at our requests, look at our limit. We want to make sure that they're appropriate and that we scale up in the right way without wasting too much waste of resources. We also worked really hard on improving our CPU and our GPU utilization. What this means is that we wanted to make sure that we weren't, again, wasting resources. So we had to look at the instances that we're using, pick the ones with the best sort of CPU, memory, GPU ratio. And we also wanted to pick the instances where we could sort of put more on the machine. We also leveraged batching in some places. Some detectors were ready for it, others were not. Some we're still working on, but that's also a quick win. Not a quick win, but that's a big win. And finally, we also reduced our invent loop lag. Oh, I have this. Okay, so here's just one example, making progress. You can look at our GPU utilization over time. And so we're going along, not good, again, low utilization. And then after implementing some changes, you can see that we're hitting 85% utilization. And this is significant because now it means that we can, with less machines, we can still have a high throughput. Okay? So some of these optimizations that we were looking at are really focused on our KPIs of latency, success rate, and throughput. And other ones are because we don't want to solve this problem with money. Right? We still need to keep cost awareness in mind. It's something that we will calculate after the fact, but it's always at the top of our minds. Remember, we said we have a budget. The budget takes margins into account. And also, at the end of the day, these are running at a huge scale. We can't have everyone here losing all their money. So we ran on load environment. We did it. We did all the optimizations, and we built confidence. And we saw that on load end we were able to do it. Right? On load environment, it's not real production traffic. We're synthesizing traffic using K6, and we built confidence. We said, great, we're good. And then we said, we're lucky because we have a time machine. Now, what does this mean? And not everyone has a time machine, but we do. So what we have is basically, remember, we bought Spectrum. We bought this company, and we still had all their servers and all their systems up with all of their client production traffic going through, right? We were still supporting that. And what we were trying to do is to move everything to our own infrastructure. And so that meant that we knew what was going to come, right? We could look at Spectrum systems and say, that's what is going to look like. That traffic is going to come to me really, really soon. So what we did is we said, let's mirror it. Okay, so we used Envoy, and we basically just mirrored their traffic over. So the clients knew nothing, right? They're still getting the requests, everything's the same, but now I'm able to basically pretend as if I'm getting all their traffic. But the place that you do that is in production. And so again, we built a lot of confidence in load-in, but we said, don't tell anyone we're testing on production. We did it very carefully. We isolated it. We made sure that it wouldn't affect any of the real clients, and we started mirroring the traffic, and we started with like 1/10%, and then 1%, and then moved our way up. And basically, this helps us understand if what the fidelity was between load end and what we'll really see. How much does that reflect reality? And so again, in this situation also, we started high because we didn't really know what our HP and what our auto scaling would need to be. We didn't want to take a risk. We didn't want everything to crash. So we started really high. We over-provisioned, and then we configured it and started bringing down until our HPA kicked in. When our HPA kicked in, we knew that that's where we needed to be in terms of our resources. We had all our dashboards set up. We measured and we monitored our alerts. Again, tracking our core KPIs. Remember why we're doing this is because we want to make sure that we have low latency, high success rate, high throughput. And finally, we said, okay, cost we'll measure after the fact. So here's an example of our dashboard. These were some of the things that we're looking at. In addition to the things I mentioned, we were also looking at our utilization, our resource utilization, again, for cost stuff. Also, we looked at the event loop lag. We looked at the number of messages in a queue. That's more for our asynchronous systems, but that's also something that we look at. And we look at pod crashes. Right? And we don't just sit around all day looking at dashboards. We also have alerts and monitoring and on-calls, and we hang out together sometimes at 4 a.m. But we have this trigger, and so when we set up this test on production, it was, everyone was ready, looking at we made sure we had all our alerts ready, all the dashboards were good to go, and we started monitoring. And what you can see here is that our success rate is looking good. You can see up here the request rate, we have the latency, and the lag and so forth. And so we're constantly on this and looking, and since this also helped us in advance to sort of ensure that all of our production dashboards had everything that we needed. And as promised, we calculated cost after the fact. There's ways to do it during, and that's what we're working on putting, so we'll actually have like a real cost metric in live. But what we did for this particular test is after the fact. So here's an example, again, fake, of just the different time windows and the cost. The different colors are different AWS services. And what you see is you can say, okay, well, we'll take the time of the test, however long the test was, and we'll compare it relative to a baseline. Now, that baseline can be the same time, previous day, previous week, previous month, can be right before. The choice of baseline is important, right? Because you can have baselines that fluctuate really, really widely, and based on where your baseline is, you might be over or underestimating. So you need to think about it a bit. And then you take the difference between them, and that's you see the test minus the baseline. You divide by the number of requests that you had during the test. Again, multiply by the number of seconds per month, because that's the budget that we're looking at, and you get a number. And this is basically how expensive would it have been to have 1 request per second per month with the resources and with the setup that we had. Okay? Notice, again, these are fake numbers, but initially we didn't meet the budget, right? And this is all a work in progress, right? Constantly doing more optimizations, constantly shaving off more cost, shaving off more time, increasing the throughput. And also, this is one way of calculating cost, right? This is basically, we said we have all the information, let's just calculate the cost. But there's other ways to do it. You can also do it in more controlled environments. Here, like I said, the noisy baseline, it's tricky, okay? So what did we learn? So dashboards are your best friend. And if you don't have good enough dashboards, invest in good enough dashboards, because that's where we start, that's how we investigate. And we understood how important it is, or we knew, that we need to instrument our code, right? We need to invest time in metrics, because that's the only way to really spot our weak spots. We need to have a deep, deep understanding of our services, of our performance, because that's how we're going to start making them better. We also ran profilers a lot. That helped us gain insights, but there's always sort of this asterisk to keep in mind that they can have implications on performance, okay? And so you have to look at them and do it carefully and be aware what it is that you have turned on and off, and especially in production. Load balancing is not straightforward, right? It needs to happen, and you're like, okay, I have, Nginx, everything's going well. But if you don't tune it properly, then you're going to end up in a situation like we were. And it took us a while to sort of figure out and pull ourselves out of this hole of ensure that the load balancing is actually doing load balancing. Scaling out is not a substitute for efficient code. What do I mean by that? I mean, you can't always solve everything with money. You can, but that's kind of defeats the purpose, right? So you need to invest in efficient code. You need to look at where your weak spots are. Don't immediately say, I'll just, spin up more. And calculating cost is an art. That's something that we're still working on, that we're still talking about. It's an active discussion. There's like, they say like 3 people, 15 opinions. It's that. Tests on production are really scary. This was really, really scary. And we did it with all of the checks in place. But you know what? The real world is also really, really scary. And clearly I have a bit of an appetite for risk. It's not for everyone, but it was super, super, super valuable, because the things that you learn in a controlled environment with K6 on synthetic data is not what you're going to learn when you hit production. And if you can reduce your surprise when you get to production with real clients and real data, it's helpful. And finally, I think the biggest takeaway is that we really have just amazing, amazing people that are super dedicated to doing this the right way. We all care about what we do and care about doing it right. So if you liked what you saw and you thought this was interesting, you have 2 assignments. The first is we have an engineering blog. Feel free to check it out. We're updating it as we speak. And the second one is to join us. And now more people are taking pictures. It means it was good. Thank you very much. Oh, questions? Yeah.
So you said you were scaling from 1%, 10% to 30%. Were you able to actually get enough GPUs?
To get what?
Were you able to get enough GPUs during the transition?
Yeah. So the question was, as we were scaling up, were we able to get enough GPUs? And so we're using many, not just one instance type. So we diversified our instance types. And when we're selecting which instances to take, we're also, AWS has like a spot instance availability, and so that you know approximately how often spots are available versus on demand for different instances. And so we make sure to diversify. And we need to be ready. Like, that's part of the thing, is like we need to be ready. We're like, what happens if we lose spot instances? Like, how fast can we spin up new ones? What is the lag that gives us? And so these are all things that we look at. Yeah. Mm-hmm.
Right? Do you understand, for example, beats or videos or some transit behavior in video actually, maybe in real time streaming to the public places or office places?
So the question was that I mentioned multimodality, and so if we know how to handle videos or live streams or GIFs or other modalities. So that's for another talk, but yes. So we invest time also not only in text. This was all about text, because that's like where you have just massive scale of chats and so forth, but also images and videos and audio and so forth. Live streaming is difficult. There's ways to get around it. We have some solutions for that, but it's a really tough problem. I think what's really hard and really interesting is memes, actually. You can have memes where the image is totally, and I can pull up a picture later, but where the image is totally innocent, so a picture of Anne Frank, and the text by itself is totally innocent. It's hotter than an oven in there. But when you put them together, right, these two innocent, like an innocent text and an innocent image, it makes something really horrible. And that's a tough question. And we try to take contextual knowledge into account as much as we can, but it's tough. Yes?
You started with explaining that your services are one thing, but what I mainly heard is you have a lot of expertise in the FinOps field. So does your company considers branching out because of that direction? Because there is a thirst in the market for professional FinOps.
So the question was that I talked about what ActiveFence does and so forth, but also we have a lot of expertise in FinOps, and if we're going to spin off into FinOps, so the first thing I'm going to do is going to run back to the office and say, oh my gosh, you guys a huge compliment. We actually know what we're doing. Thank you. We invest a lot of thought into this because it's something that's really, really important. If we have clients that are at this scale, if you're not careful with the costs, you're going to lose an arm and a leg. And so this arose out of need and also an interest. Like, I think we all think this is like really, really interesting. It's one thing to build models, but our models and all of our solution, our detectors and our API, they don't act in isolation in the world. Like, we're not in a vacuum. And when it gets interesting is when you're in production with clients and they're paying money and you need to earn money. So that's like an interesting intersection. So thank you. Yes. I'm going to tell them, yeah, we know what we're doing.
I have a question.
Yes.
Have you seen any usages of Gen AI in order to trick your detectors or maybe create a way that your scouters or models won't be able to understand? Have you seen usages of those technology?
So the question was, have we seen the use of Gen AI sort of to trick our models or to go against our models? And so the answer is twofold. So first thing is harmful content is harmful content no matter what, right? If I want to detect child pornography, I don't care if it's a real victim or a Gen AI victim. Like, that content should not be online, okay? There's other ramifications if it's a real victim and so forth, but either way, that needs to be detected. And what sort of Gen AI did is that it sort of increased the scale and the availability of harmful content. Because now, if it used to be that it was like you could either create really high quality harmful content at a low scale, or like tons of harmful content that was low quality at a high scale, and now you can do really high quality harmful content at a high scale. It makes it very, very easy for bad actors to do their deeds. And so what we see is that now there's even more scale of this, and like our models need to deal with it. And in terms of like specifically tricking, because I mean, if they sort of tricked it in terms of like doing something that doesn't really seem harmful but is harmful, so that's stuff that we're working on in our models because humans do that too. It's not something that's unique for Gen AI. I will say that we also utilize, Gen AI in-house, right? We want to make sure that we can use it to help us rapidly improve our models, to sort of ensure that we have functionalities, that we're able to cover all the functionalities to help us generate it, reduce bias, and so forth. And so it's a tool that we also use, but it makes our lives really interesting. Yep, thank you.